Dear students, welcome to Statistics and Dynamics, and thank you for tuning in to this video. I am Dr. Loay Al-Zube, and we are going to continue our coverage of the content of the Statistics and Dynamics course. This is lecture 4. Previously, on the previous lecture, we talked about how to add forces and how to resolve them in 2 dimensions, as well as how to determine the vector's magnitude and direction in 2D as well. A lot of structures and machines in real life are in 3 dimensions, and we want to move one step further and talk about how to represent a 3-dimensional vector in Cartesian coordinate system, and how to find the magnitude and the coordinate angles of a 3-dimensional vector. Now, we're going to introduce this new concept, which is called the coordinate angles. We're going to learn what are those and why they are important in 3 dimensions. Also, we're going to talk about what is the unit vector. This is an extremely important concept in statistics and dynamics. At the end, we will talk a little bit about what's the difference between what we are probably used to as projection angles as opposed to what we introduced in this lecture as coordinate directional angles. So how are those 2 angles are different from each other? We're going to talk about those. Let's start with representing a 3-dimensional vector in Cartesian coordinate system. Many structures and machines, as I said, involve 3-dimensional space. The image that you're looking at, the power pole has wires helping it to stay upright in high winds. How can we find or represent the forces in the cable? So you can see you have FA and FB. So those are the forces here. This is FB and this is FA. When we want to resolve or solve problems in 3 dimensions, the vector operations are simplified if the vectors are first presented in Cartesian form, which means that we have component in the x direction, its x-axis, a component in the y-axis, and a component in the z-axis. Note in this image here that we have distances that are presented in the figure. So you know that point D here is away 3 meters from the x-axis, and it's 2 meters away from the y-axis. How are we going to use these values in our vector analysis and vector algebra and presentation? So we're going to talk about that. I want you to draw your attention to something. If you look at this problem, there's something missing here, which is the values of FA and FB. So is it 50 newtons or 20 newtons? So we need to have a complete set of information in order to be able to solve such problems. So let's look at a real-world example with a complete set of information to use. We have this radio tower. We know the forces in the 3 cables. So you have 3 cables. Can you see one that has 600 newton, the other is 400 newton, the second and the third one is 800 newtons. As we've seen before, we also have the distances, which are the coordinates in the space, right? So you are for point C, you are 18 meters from the x-axis and 16 meters from the y-axis. Those are very important. We're going to use them a lot. This is a real-world example, and the question will come to you is, how would you find the resultant force acting at the tip of the tower, so at point D, knowing the information? So you know the forces in the cables, and you know also the location, the coordinates of the locations of them, the ends or the attachments on the ground. We're going to be learning how to do this. Before that, we need to introduce some concepts. So we will start with something called the right-hand coordinate system. This is what we're going to be used to develop the theory of vector algebra that we're going to be using along the semester, along this course. A rectangular coordinate system is said to be right-handed if the thumb of the right hand points upward to the direction of the positive z-axis. As you see here, this is the thumb. When the right hand fingers are curled about this axis and directed from the positive x-axis toward the positive y-axis. So these are the fingers that are curled. So this is the x and this is y. And by doing this, using your right hand, you establish the rectangular coordinate system. So we know where the z-axis, we know where the x-axis, and we know where the y-axis. Please note that we have 90 degrees between each pair of these axes. A vector A may have 1, 2, or 3 rectangular components along the x, y, z coordinate axis in 3 dimensions. And we're going to talk more about this, and we'll solve problems. If we are good with the rectangular coordinate system and the right-hand rule, so we have our space identified. We need to introduce now another important concept that will be frequently used throughout the course, and that is the concept of unit vectors. Unit vectors are very important. We're going to use them a lot in our analysis. So we need to grasp this concept. So we have two cases, one called the general case and the special case. So you know the unit vectors, the ijk, with the I for the unit vector of the x-axis, and the j is a unit vector for the y-axis, and the k is a unit vector for the z-axis. And we know that the magnitude of all of those is 1, and they're dimensionless. So we have established this in previous courses, and we talked about this. This is called the special case of the unit vectors. There is a general case of unit vectors. So I can give you any vector. So let's say the vector from D to C that has 600 newtons, and those are the coordinates of it. We can find a unit vector for that vector actually, not just for the x or y or z. To calculate this, you need to have your vector presented in the x, y, and z in the Cartesian coordinate system, and you divide that vector, or the vector that you have in x, y, z, by the magnitude of the vector. And this is how you introduce something we call the unit vector of vector A. So that's the general case. We're going to learn how to use this in class, and we are going to practice it with a lot of examples so that you can grasp it. This is the concept of unit vector. I hope that you have a good idea, a general idea about how we're going to use it. Keep in mind, we have a general case so that I can find the unit vector for any vector in space, and we have the special case that we have the unit vectors for the Cartesian coordinate system, which are the I, j, and k. Alrighty, so we go to this point. I'm going to stop this part of the lecture here and this video, and I will continue with the second video of this lecture